This is Algebra 2 review for the Semester 1 final exam. In this video, I'm going to go through numbers 1 through 6, all these multiple choice questions. And for many of these, especially number 1, you're going to find you have a couple different ways you could do this. So number 1, we're asked to solve the equation and check for extraneous solutions. Now when you look at the equation, one number that pops up that we should avoid is -3, because if we plug in -3 to w, that makes the denominator to 0, which means it'll be undefined. You can't divide by 0. So then when they're saying check for extraneous solutions, that's the kind of solution that we want to avoid. Now there's two methods to do this. You can, what I'm going to show first is the common denominator method. So I'm going to rewrite the 5 over w plus 3. On this side I have 5, but I'm going to factor the bottom here, w squared minus 9. That's a difference of 2 squares, which means when I factor out, I'm going to get w plus 3, w, well, it's small, w minus 3. And I did that because I can take the square root of each of these. That's why, and it's a difference, that's why it's a difference of 2 squares. Now when I do that, I can get a common denominator on this side. So what I'm going to do is I'm going to make this match this denominator. And what I'm missing is this w minus 3. So I'm going to multiply both the top and the bottom of this side by w minus 3. Now when it happens, the nice thing about doing the common denominator is when I get here, since these are exactly the same, I can just cancel those completely out, and I'm left with just the 5 equals 5 times w minus 3. Whatever, bell. Now when I get here, I'm going to distribute this 5. So I'm going to have 5w minus 15. Add the 15 to both sides. I get 20 equals 5w. I'm going to divide by 5, and I get w equals 4. And notice 4 right there. And again, it says to check for extraneous, so if I plug the 4 in, I'm not going to get a 0 on the bottom of the fraction. It's going to work out nicely. So my answer for number 5 is A. Now the other method, if you didn't want to do the factoring, you could 5 over w squared minus 9, 5 over w plus 3. You could cross multiply, where I'm going to get 5 times w plus 3 and 5 times w squared minus 9. Distribute. Or what you could actually do, one little trick, you could distribute the 5s, but if you look at both sides, I can actually cancel these 5s because they're not separated by any addition or subtraction outside the parentheses. I can get rid of those factors, so I'm left with w plus 3 equals w squared minus 9. I'm going to move everything to this side with the w squared, subtract w, subtract 3, subtract w, subtract 3. So I get w squared minus w, combine these, I get minus 12. Now, hopefully you're good at factoring, where I can get w minus 4 and plus 3. This is one of those diamond factoring problems. Negative 12 on top, negative 1 on the bottom. Negative 4 times 3 is negative 12. Negative 4 plus 3 is negative 1. This results in 2 answers. When I put each one equal to 0, I'm going to get w equals positive 4 and negative 3. But the thing about this method is that you have to check both of these. Negative 3 doesn't go in there, makes that a 0, which means it is the extraneous solution, so there's w equals 4. So you have 2 different methods, both that work just fine to solve number 1. Number 2, milkshakes at the movie theater cost $2 for a small and $3 for a large. If 31 milkshakes are sold today for a total profit of $76, how many small milkshakes were sold? $2 for a small means I can start one equation with 2s, $3 for a large, 3l, equals, and since these are the dollar amounts, I want to look for the other total dollar amount, which is the profit of 76. My second equation would be s plus l, just the number of total milkshakes. Small milkshakes and large milkshakes, there were 31 sold. Now if they're asking me how many small milkshakes were sold, that means I'm solving for s, which means I have to eliminate the l. So I'm going to take this bottom equation, I'm going to multiply by -3. because then 3L minus 3L cancels, times negative 3. This now becomes 2S minus 3S, that's negative 1S. When I multiply these, I get negative 93. And now I'm going to combine negative 93 with 76. I get negative 17. Divide by negative 1, and I get positive 17. And there's 17 small milkshakes. Now you could work kind of backwards. You could try the dollar amounts. A little bit confusing, but if you wanted to, as a second method, if the question's asking about small milkshakes, so these will be all the small. Now if you have 17 small, that means you have to have 14 large, because remember that these have to add up to the total of 31 milkshakes. Now if there's $2 for each small, I'm going to take 2 times that, $3 for each large, 3 times that, 2 times that is 34, 3 times that is, that's 42, and I add these, I get 76, and there's the dollar amount that they mentioned earlier, $76. So this way, it's just kind of, it's going backwards, it's not using variables or x's, but it can still get to the same answer, but it might take a little bit longer because you have to do all this work. And keep in mind, if this didn't work, if you didn't get 17, you'd have to test 14, and then 15, and 16 if those didn't work. So another method, both work again just as well. Number 3, really only one method for number 3, simplify the rational expression. So now we're meant to take both of these, we're going to factor both top and bottom. I'm going to factor the top, I get negative 8 on top of my diamond, negative 2 on the bottom, negative 4 and positive 2 work because they multiply to give me that, add to give that. And since it's a 1 in front, I can go straight to this. So it becomes n minus 4 over n plus 2. Then I factor the denominator, negative 6, negative 1. And then negative 3 times positive 2 works there. Multiply and it gives you that. Add gives you that. Again, right into this, n minus 3, n plus 2. N plus 2's cancel. I'm left with n minus 4 over n minus 3, which is choice D. Number 4, which of the following is not an x-intercept of this? Now when we're finding x-intercepts, what we're doing, we're really finding the roots of this equation. So what we're doing is we're taking the f of x, which is normally, it's kind of like y, we're making that equal to 0. Because the x-intercepts happen if we think about our graphs. X-intercepts would be on the x-axis like these points, where y is 0. So we're going to take this from here, x cubed plus 4x squared minus 4 minus x minus 4. Now on this equation, when we're solving this, hopefully we can factor by grouping. So what I'm going to do is I'm going to split this down the middle. I'm going to take a common factor out of each side. On this side, my common factor is x squared. When I take that out, I get x plus 4. On this side, my common factor is negative 1. There's no other numbers that go into both. This doesn't have the x, so it's just negative 1. And then x plus 4, which is nice because factoring by grouping works since the x plus 4's match. So now my two factors become x plus 4 for one of these ones that matched, x squared from this first factor, minus 1 from that one. Now you do have to check and see if this still factors. This does factor again. So I have the x plus 4 on the end. And remember, this is still equal to 0. This is difference of 2 squares, so I can make that x plus 1, x minus 1. Excuse me. Now the nice thing is for all three of these, the x's have a coefficient of 1, which means I can just change these signs. I get negative 1, 1, negative 4. There's the three zeros of the equation. Negative 1, 1, negative 4. It says which is not an x-intercept. Positive 4 is the only one that's not listed. And that goes right there. Now the other way, there is another way to do this. If you wanted to, I'm going to get rid of this. Put a little work there, and then let's say if you didn't know how to do the factoring, if you had trouble with the factoring, as long as you understand the concept of it being an x-intercept, you can plug this number in. Now this is saying at 4 I'm going to get a 0. So I'm going to take this f of x or the y, I'm going to replace it with 0. I'm going to take this x value of 4, I'm going to plug it into all these. So it becomes 4 to the third plus 4 times 4 squared minus 4 minus 4. 4 to the third is 64. This becomes 4 squared is 16 times another 4 is 64 minus 4 minus 4. Combine all of these and I believe you get 120. Since 0 does not equal 120, that is not an x-intercept. Now if you did that with negative 4, it would be negative 4, this is going from choice B, cubed plus 4 times negative 4 squared minus negative 4 minus 4 plugging it in. This would result in negative 64 plus 64 plus 4 minus 4. These cancel each other out. These cancel each other out. You're left with 0 equals 0. That's why the choice B works. So if, again, you have to understand that the x-intercept is asking for when it's y equals 0, but you can plug it in. Instead of doing the factoring, you can plug it in, see if it ends up being 0 equals 0. If not, then that does not work. It all depends on this wording and what you're looking for in the problem. Number 5. Again, another one where we have to solve the equation and check for extraneous solutions. I'm going to start by simplifying this addition problem on the left side of my equation. So I've got a over a minus 12 plus 4 over a. Now to add these I need common denominator. My common denominator will be the two factors, a minus 12 and a. So on this side I'm missing an a on the bottom, so I have to multiply by a, both top and bottom. On this side I'm missing the a minus 12, so I have to multiply both top and bottom by that. So my common denominator is a times a minus 12. Then on top I have a squared, this a times a is a squared, plus, and I'm going to distribute that, plus 4a minus 48. Now this is actually the addition problem for this. Now I'm going to bring back that equals 1. I'm going to put it over 1, and I'm going to cross multiply both of these. So I'm going to do this is multiplied by 1, so it doesn't change, a squared, plus 4a minus 48 equals. Now I'm going to go ahead and distribute this. So this all times 1 won't change it, but I will distribute the a. So it becomes a squared minus 12a. And now if you look at what I have here, on both sides of my equation I have a squareds. If I subtract a squared, it's going to cancel, so I can just go ahead and cancel those out, get rid of them, they're gone. So now I'm trying to solve this, what's left over for a. I'm going to keep the negative 48 there. I'm going to subtract this 4a minus 4a. Here I'm going to combine these, I get negative 16a. Finally, I'm going to divide by negative 16. And that when I divide is going to give me positive 3. So my solution there is positive 3. Now it's not extraneous. If I plug the 3 in here, it's not going to become a 0. Not going to become a 0 there, so it works. The only extraneous solution would be if I got a 0 or if I got 12, because 12 minus 12 is 0. But that works. 3 works for the value of a. Number 6, the last one, factor the polynomial. Now if you remember before on number 4, I drew a line down the middle, I tried to do the grouping. I'm going to try that here as well. So I'm going to start with 12x cubed minus 8x squared minus 3x plus 2 down the middle. On this side I've got an x squared common. I can take an x squared out. But I can also take a 4 out because 4 goes into both 8 and 12. Divide these, I get 3x minus 2. On this side I've got negative 1 that can come out, and that's it. Positive 3x minus 2, and that works. So I've got 3x minus 2 for the common factor. The common terms I took out, 4x squared minus 1. So I look at my answers, 4x squared minus, I don't see 4x squared minus 1 anywhere. I do see the 3x minus 2. So 3x plus 2, that's not going to be A. But it could be any one of these. Now I compare this, 4x squared minus 1, 4x squared plus 1. It's not going to be that one. So chances are this is going to factor again. So I'm going to leave the 3x, or keep the 3x minus 2. And this is a difference of 2 squares, because I can take the square root of each of these. The square root of 4x squared is 2x. The square root of 1 is 1. Plus, minus, there's my difference of 2 squares factored. There it is in choice D. Now the other option too, you do have an option. If you don't remember the factoring by grouping, it would take a while, but you can multiply these all out. You could do foiling or distributive property, or whatever you refer to it as. Multiply them all out, and the first one that's going to work is this one. The only thing is it's going to take a long time to multiply all that out. So it's really better if you can remember all these different kinds of factoring.